Hey guys, today we're doing Chapter 9, Section 5 for FST, which is the factor theorem. So the factor theorem relates the zeros, or where the graph crosses the x-axis, which are also called roots, of a function to the factors of the polynomial. So essentially we've been talking about factoring and we've been talking about dividing polynomials in order to find the factors or get it into its factored form. And now we're going to talk about why we've been doing that. Basically, we've been doing that because our factors are the same thing as our roots or our x-intercepts. And we can use those factors in order to graph equations. So the factor theorem states that for a polynomial f of x, a number c is a solution to f of x equals 0 if and only if x minus c is a factor of f. So essentially what that's saying is that c, which is like our factor, it is a solution to the equation when y equals 0. So in other words, I kind of like to think about it the way we talk about quadratics. So you know that when we solve for the roots of a quadratic equation, we're setting our y value equal to 0. And that's how we use the quadratic formula. Yeah, couldn't think of it. But the quadratic formula is essentially we're setting our y value equal to 0 and then we're solving for x. So what we're doing here is we're finding the values of x when y equals 0, but we're doing it with factors instead of using a formula. So this is only true if x minus c is a factor. We also have the factor solution intercept equivalence theorem. And this is really important because just from knowing that something's a factor, we can deduce a whole bunch of other things about it, other statements that are equivalent. So if I know that x minus c is a factor, not only do I know that f of c equals 0, in other words, if I plug that number in for x, I get a 0 for y. I also know that c is an x-intercept of the graph, so I know that that's a point where my graph is going to cross the x-axis. I know that c is a 0, okay, or a root, and I know that the remainder when f of x is divided by x minus c is 0. Okay, so there's a ton of stuff I know if I can figure out what my factors are. So let's do this first example here. I want to factor 6x cubed minus 25x squared minus 31x plus 30. Okay, so where do I even begin? I'm not really sure. I could think about my difference of squares, my sum of squares, all those special factoring formulas, but honestly I don't think that's going to help me on this one. So a good place to start would be to start by graphing this function. So on my calculator, in my y equals, I'm going to type in this function 6x cubed minus 25x squared minus 31x plus 30. And I'm going to look at this graph and try to figure out if there's any hints that I can find. Okay, so I just have mine on a regular negative 10 to 10, negative 10 to 10 window. And I can see the roots pretty close up, so I can get a good idea of where it's crossing the x-axis. If I want to find exact values of crossing, you could either use your table or you could use the second trace function on your calculator and go to zeros, and it'll actually find the 0 for you. What you should notice from your equation is that it's going through 5. So right away I know that 5 is going to be a root of this function or a 0 of this function. So what I can say is that 5 is a 0. And from that information, I can deduce a whole bunch more stuff. If I know that 5 is a 0, then I know that x minus 5 would be a factor. So that means that I can divide this function by x minus 5, and then I can use that to factor it down further. So that's what I'm going to do. I'm going to say x minus 5. I'm dividing this function by that. And I'm just going to do my division of polynomials here. So I take, what do I need to multiply this number by to get this number? It's going to be 6x squared When I multiply it through, I get this, then I subtract. I'm going to bring this down, and I know that this is going to be 5x. Then I can subtract and bring this down. And I get a remainder of 0, which is what I should have gotten. So I know that x minus 5 is going to be a factor of this, which is what I knew right away, but now I can actually write this in the factored form. So I can write this as x minus 5 times 6x squared plus 5x minus 6. Now looking at that function here, I need to think about how I can factor this down even further. So one way that you can do that is using your x game. So let's go ahead and try that. I know that I'm looking for two numbers that add up to 5 and then multiply to negative 36. Okay, so two numbers that add up to 5 and multiply to negative 36. Right off the top of my head, I think of 9 and 4. So I know that I'm going to have a positive 9 and a negative 4. So now I can rewrite this as 6x squared plus 9x minus 4x minus 6. And then I can group it. I can't forget about my original x minus 5 over here either. So now I can pull out my factors here. So from here I can pull out a 3x, and I'm left with 2x minus 3. From here I can pull out a negative 2, and I'm left with 2x minus 3, 2x plus 3. Sorry. Okay, so now I can regroup these. So I'll have 3x minus 2 times 2x plus 3, and then I need to have my x minus 5 in here as well. So what I've done is I've factored this all the way down now, and this is my final answer. Okay, the next question, I want to find an equation for a polynomial function p with zeros of 2, negative 4, and 4/7. Okay, so if I know that those are zeros of my function, I can write those as factors. So remember, it says that f of c is a 0. That means that x minus c is a factor. So I can write this as x minus 2. I can write this as x plus 4. And I can write this as x minus 4/7. Okay, the problem is that when you have a function like this, there's a lot of ways that you could get the same zeros. So what we like to do is we like to think about these fractions here. We like to change them so they're not fractions anymore, because it's kind of icky to deal with fractions, especially if you're going to multiply this all out again. So if I think about this using my zero product property, I know that if this is all equal to 0, which is what it is since these are all zeros, then this would become x minus 2 equals 0, this would be x plus 4 equals 0, and this would be x minus 4/7 equals 0. So I want to think about something else that I could have that when I solve it, I would get a root of 4/7, but it doesn't have fractions in it. So what I'm going to do is I'm actually just going to multiply this whole thing here by 7, and I get 7x minus 4. So if you think about that, that doesn't actually change anything, because if I were to set this equal to 0 and solve it, I would still get 4/7 as my 0. So I'm going to write this as x minus 2 times x plus 4 times 7x minus 4. And this is going to be my factored form of my equation. And you could also have an a value in the front, and that just kind of changes how stretched out it is. but you don't have to actually solve for that. You could just call it 1. Basically, whatever your a value is, you're still going to have the same zeros. It's just sometimes they might give you a specific point that they want on the graph. And if they have that, then you might have to solve for a. So this would be my function here. All right, that is everything for section 5.